Yeah. Hi everyone, my name is Nick, and I think as well, thanks for coming along to this. I'm just going to show you, just with the R programming language, how you go about doing end-to-end data science with R, and how R is not a bad language to use for a hack. So we'll go through everything from getting some data, importing the data into the R programming environments, doing some cleaning of that data set, some wrangling, some exploratory analysis, and we're also going to build a predictive model, and then we're going to build a data product, which is going to be a web app all within the R programming environment. So it really does make your life easier to do everything sort of end to end within the one space. So it's yeah, feel free to ask questions as well. Pretty informal. So if you want to see what I'm seeing, head over to Masterclass there, and you can see I put a link up for the workshop, very similar to what James did. So it's running in Google Colab. So you'll be able to not have to install any software or anything like that. I've set that all up for you. So you can just sort of click go on Google Colab. So what you do is you click on this link here. Hopefully you can see that. And that will open up here. And so this is GitHub, and yeah, let me know when everyone's there. Cool. And you can just go, and this is where my notebook's hosted. You can see it there. But if you want to run the cells, you can open in Colab. And then we're ready to go. So actually you can try running the first cell just to make sure that that's going to work correctly. So control and enter to run the first cell. You'll get a warning, but just run it anyway. And that should, yep. Yeah, that should work. Yep, cool. Yep, okay, that's working. So what this is about is, in Australia, there are lots of, usually you need to understand the problem of what you're doing first before you actually start analysis. But there was a lot of scrutiny around banking in the last few years, and you need a couple of different types of licenses, either a credit license or a financial services license if you're working in banking, depending on what you're doing. So if you've got a credit license, you're able to lend money. If you've got a financial services license, then you're able to advise people about insurance products and that sort of thing. So what I was interested in is I found a couple of data sets, but has the regulatory environment and the changes caused some sort of change in the distribution of the two licenses in the last few years? So I was kind of curious about that, and that's really a prompt for our analysis. And even in your own work, it really is important to narrow the scope of your analysis to something fairly concrete like this before you start a data science sort of project. So that's what we're starting with. Now if you head down a little bit. So the power of a programming language, and even a language for data analysis like Python or like R, really is in the modules and the packages that make your life easier to wrangle. And so you don't have to invent things from scratch. You can leverage code that other people have built and tested. And some of that code is found in the tidyverse, which, does anyone know of the tidyverse? It's written by this Kiwi guy, Hadley Wickham, who's like, he wrote a whole set, like the Swiss Army knife of cleaning data and plotting data and wrangling data within R. So it really makes your life so much easier. It's a beautiful, beautiful work. Lubridate as well is around managing dates and putting dates in different formats. And I've also got some options there which are really about the plot height and not making them too large or janky within this notebook. So I'm just going to run that code. There we are. And so that's run. There's nothing really to output there. And now, with these packages, a few of them do come with this notebook environment, but you can also reach out to a whole bunch of people who create these packages, and they host them on the CRAN website, which is like a repository of all these packages for data science. And one of them is actually this package called Shiny, which allows you to create interactive web apps. And so we can just install that. But while it's installing, I'll show you actually the finished product, because this is a hosted runtime that I have in Google Colab, so you can't actually see the end result. I can take you to the end result, but I have to jump back to the IDE here. But this is what we're going to end up producing, and this is the shiny part of the tutorial. But I'll just run the code down the bottom there. And this is what we're able to do with the R programming environment. We're able to build this interactive web visualization, which, like, I'm not a front-end web developer. To think of me doing this sort of work is comical. But I can pull something like that together in just a little bit of code, or within R. It really does lower that barrier for allowing us as data scientists and data analysts to do some really cool stuff. So I really highly recommend you look into the Shiny package. And it's responsive, you know. So to code this up with JavaScript, like, I wouldn't even know where to start. But when you look at the final product, there's only really a few chunks of code that's doing all this. It's really that simple. But I'll walk you through it. So anyway, it's still, I thought it would have been done now. It's still installing. And so it's not only just installing the package. When you reach out to the CRAN library, it will install some dependencies as well. So everything else that package is going to rely on. So in a similar way with Python, you have packages and modules. You also have that with R as well. So any questions so far on anything that we're doing? Or so far we're just getting stuff ready. And this is unfortunately taking a little while. That should... No. Yeah, okay, I'm surprised that that's taking as long as it is. It should. That's weird. Well, anyway, I can keep going with my backup, which is here. So, while that's still strangely installing, oh yeah, absolutely. So this data is, if I go to my code that's not working, is here just on a government data site. There. Yeah, that's it, just downloading just there. That's right, yeah, they would. I don't think they'd... this is sort of the regulator who oversees some banking. They make some of this stuff available. Yeah, that's right. Yeah. But, yeah, apologies about that. I'm really surprised that that's not working. Anyway, I can push on, but with this code here. So, okay. So, I might make this... Can everyone see the writing there? Is that large enough there for you? Or I can make that a bit larger if you want. A little bit, yep. Okay. Okay, that may be too large, but is that okay? Good. Okay. Excellent. So I'll change over this one. That's okay. For some reason that didn't work. But this is the way that we can read data into R. It's as simple as read.csv. I mean, that's fairly intuitive, and this data is sitting locally on my machine. It'd be the same process if it was sitting out somewhere on the internet. You just put in the URL string there, and off it goes and finds it. So when I do this, this is the financial services license data set, and this is the credit data set. So you can actually click here as well in this environment and have a bit of a look at your data, and that's there. And you can sort of scroll around and check it out and make sure it's all imported correctly, which is pretty neat. You can also use this really helpful function, the str function, which gives you an idea of, I think of it as like the structure. What's the structure of my data? And so when I run this, I might bring this little window up, but it gives me a little bit of information about the different. So I've got 6,248 observations, I've got 13 variables. It tells me about the different variables. It tells me what type of variable it is. It gives me some examples of the data there. It's a really good way of getting a sense of what my data looks like. I can do the same thing with the credit data set. And there we are. Yep. So I can see, 5,301 observations, 17 variables, something, register name. What it means by one level is just it's all credit license all the way down. Another example, credit license number, gives us a whole heap of examples. That's an integer, a factor, and so on. So I can get a bit of a feel for what's going on in my data set. Okay, I might see how my little Colab thing's going. Oh yeah, no, I think that's okay. I think that's all right. Yeah, okay, so that has installed now. Sorry about that. And then we just want to run this. So now we have that library available to us. Okay. So now apologies about this, but I'm just going to jump back here. And so the data set actually online is in a slightly different format. So rather than read CSV, we're just doing read.table, which is another function to read in the data set, which is also available. But it pretty much is saying, reading, I've got AFS underscore file as that path, read table, that path, the separator is a tab separator. I want the headers and any comments I want to treat there with I don't want any special comment characters, and I want to ignore quotes there. And so that's worked. Okay, so the credit file, that's that link. So is anyone following along with this? Does anyone have, cool. So how do you think we'd go about reading in the credit file? I'll help you out, okay? It's going to be pretty similar to this. So yeah, if you want to have a go at that, feel free. If you want me just to go ahead and show you guys the answer, that's okay as well. But to read in the credit file is really similar, right? So you've got a link to the credit file there, separators tab, headers true, almost exactly the same thing, almost a copy paste. And so we read that in. We can check it out with this tail command that will give us a look at the bottom few observations we have. There we are. So you can see some of that, some observations there. Okay. So I did talk through the str function. Another good function is this summary function. And also that can tell us about our data set as well. So for each of the variables, it can tell us for the numerics, the mins, the max, gives us an idea of the range. For some of the factors, it gives you an idea of what they look like as well, what typical observations are as well. So if you want to, you can go through and have a look at the two data sets, because they're not really, we want to combine them into one data set, and it's not really easy to do that. So we need to do some data wrangling. So when I look at some of the variables, actually let's just do this. Yeah, I'll show you what the first observation looks like from the AFS dataset. You can see AFS license number, AFS license name, AFS license ABN, etc., etc., etc. Now from the credit dataset, you've got a problem because you've got credit license number, credit license name, etc., etc., etc. So they're not the same names. So we have to clean those names to be able to join these datasets together. And so what we've got, this is actually more explicit here when we show it. We've got, of the AFS dataset, we've got this, AFS license name, AFS license number, and the credit dataset looks like this. So there's like a prefix that we've got to remove, which is a bit painful. But in R, that's actually a pretty easy thing to do. So what I tend to do with these sorts of tasks is I write a function, and this is an example of a function in R that I can write, where this is all this is saying is, for a given prefix and a given data set, I want to substitute the prefix with just truncate it, make it go away, and for all the names of that particular data set. So just like we did the names before, like there. So anything like this credit bit, I want that to go away. And the AFS bit, I also want that to go away. And this function will do that for both data sets. So if I run that, and so if I use that function here, which I call rename calls, and the prefix I want is this AFS prefix on the AFS data set, I can run that and that will strip out that AFS underscore part. And the only other problem is if you look at the AFS data set as well, they have this add thing, which is another kind of bit of text which isn't common to this data set. It doesn't have the add, so I'm just going to remove that as well. And I think there's a difference here between local and locality, which I need to just rename. So this one's got locality, and the one above it has local. So that's just a bit of data cleaning, which I'm going to do. And the effect of doing this, just running this, is if I show you names of the AFS data set, then look at that. We've gotten rid of the prefix, we've gotten rid of all the mess, and it's just like a nice, we've cleaned up all the names of the data set. And so we can have a go at doing that for the credit data set. Does anyone have any idea of how we'd strip out that cred part of the names there, or somebody to go ahead and do it? I can show you. It's using that function which I created, passing in that cred underscore for the credit data set, and then our data set names are going to be like for like. So we've just cleaned up our data set just like that with a couple functions. So we might have noticed that not all the names are common to both data sets, but what we can do there is we can just do this. So this is subsetting the names of our AFS data set where the names are in the names of the credit data set, so where there are common names, and then we can select out the AFS names just pretty easily. And there we are. We've got the names that are common to both data set in a couple lines of code, and we can check that as well. Sorry, names common to the AFS data set that are also in the credit data set. So we've got the common names, and now I'm just selecting the appropriate ones from the credit data set. And now if I run that again, we should just have the common names for both data sets. And there we are. So now what we're able to do is to get the credit data set, get the AFS data set, and just whack them one on top of the other. And the function we do that from the tidyverse is called bind rows. And this will be the output of using that. You get some warnings, but ignore that. But essentially, actually that's what we have to do. We do have to clean up the date field here, so my apologies about that. So this is really just taking the license start date and just formatting it nicely using that Lubridate package that we brought in. And so if we have a look at that, maybe I can, actually what I'll do is I'll push on. Might just create another code cell. And this is the way that the combined data set's going to look. This is the top part. This is the AFS license data set. And if we throw in tail, this will be the bottom part of the whole thing, and that should be the credit license, and we see that just down the very bottom. So we've kind of whacked the two data sets on top of each other by the common fields. So now we're able to do an exploratory data analysis, and so what I like about the tidyverse as well is it allows you to sort of chain or pipe in these different operations that you do. So, and it reads almost like how you'd think about it. So from the data set, select that, I want to select the following variables across that line, and you see that pipe operator there? That pushes the results to the next line. So then once I've got those results, I want to mutate the year. So I want to create a new variable called year, a year of the license start date as a new variable. I want to create this new month, and the 02D there just means I want it to be, if it's less than 10, I want to just stick a 0 in front of it, otherwise just give me the month. And from there, so this mutate is actually creating two new variables. So from there, I want to then group up the data by these two new variables that I've created, year and month, and also register name, which is in fact the license type. So the license type being the credit license or the AFS license. And then once that's grouped, I want to summarize, just to create a count variable, which is just a count of the rows that I've got. And then at the very end, I just want to filter that data set for the year variable being more than 2000. So this is quite a complex operation, but when you think of it like this, and when you write it in code like that, it's actually really easy. It kind of flows off the fingers fairly easily. And so what we have then is something that looks like this. Year, month, type of license, and the counts in that particular license, which is really neat wrangling and really quite easy to do. Keeps going, sorry. So if you like, you can also have a look at why I subsetted the data for 2000. And as often happens, there are these really weird years and data errors there. So there's like the year 201, 305, which are obviously typos. So if you start to subset by 2000, you get something sensible, because I think someone must have had some problems with typing there. So then here's the other thing in the tidyverse, which is really neat. It's the GG plotting library, which allows you to, in the same way that you can subset, slice and dice data, you can create your own custom plots really easy by, again, chaining quite a lot of the complexity together. So what I want to do with this plot is the data is the summary data. The aesthetics there that I want is to have the year and the count. And I want to be able to create a bar chart. So G on bar is the next line. And I want to be able to fill or color in that bar chart by the license type. And then I want to be able to cut by the different license types. So it's a facet. And it really is, you look at it and you go, wow, that's kind of complicated, but it's really quite easy to do. And then when you plot it, you can get a custom plot that looks like that in just a couple lines of code. Sorry, it's a bit of a close-up there, but you see the AFS license there. You can see the year. You can see it's coloured differently. and that was the fill part. And you can see it's faceted as well by the license type, which is pretty cool. So 3 lines of code to create a plot, like, you know, pretty amazing. So, what am I saying here? So, if you wanted to play around, maybe when you go home or something like that, you can actually see if you can reproduce this plot, but faceted by state. And I'll show you how I did that. So this is it here. You can probably look at it later, but I can just run it. Now this is pretty cool because I can facet by the different states of Australia. So these are the different states, different license types, different colours for license types, and different years. So it really is quite powerful to be able to, in just a few lines of code, come up with these custom visualizations and really drill into and facet your data. So now I'm going to build a predictive model. So what we can sort of see is that there is some evidence that towards the later part of the data, we have a bit of a swap where there's a few more of these type of AFS licenses and not so many credit licenses. So what we can do is build a model on the previous few years to predict what we ought to have seen. And so it's just a simple model, but it's just for illustrative purposes. So again, we're subsetting for this summary data set. And here, the only thing that's different is I'm filtering by the year 2012. So now with machine learning, what we've got is the idea of training in a test data set. And again, it's really easy with the tidyverse and the filter command to create this quite simple like subset. So the first subset is anything that's more than 2012 and less than 2016. The second subset is between 2016 and 2018. So I've just got one data set here, 2012 to 2015, and then 2016 to 2018. So I'm going to train on the earlier data set to predict some of the later years. And there we go. You can have a look there just to make sure you got it right. And that's the table command that actually gives you an idea. Just sort of, it's almost like a summary of the data set of a particular variable in the data set as well. And you just see the count of observations there. So you can do some really simple plots really easily. Like just a histogram is just like a simple command. They're not particularly attractive plots, and you sort of do them when you're doing exploratory analysis, but they give you an idea of what's happening. So that's what I'm actually looking at here is I wanted to do just a linear regression, and I can transform quite easily the count on a log scale, which is just making it look more like a bell-shaped kind of curve to use in my model, and that's really easy as well. Now I can make sure, and I can really easily plot some fairly sophisticated graphs, which is like where I think a theoretical normal distribution should lie and what a line through that theoretical normal distribution should look like. And that's like a couple lines of code to do something which is pretty complicated. And so there's immense power in this language to be able to do stuff really easily. So when I take a log transform of my counts and plot them against where the theoretical normal distribution should lie, it kicks off at the end a bit, but it's not bad, and not bad for a first base model, which is really what you want to do here. Okay, and here's the model. So this is, I mean, people talk about machine learning and about AI. One line of code. It's all the other stuff really that came before it that's the complicated bit, about specifying the data, cleaning it, wrangling it. That's where I think the complexity is. By the time I'm getting to the modelling stage, like I'm taking my seatbelt off in the car, I'm pretty much done. And so all that that's saying is I want that log count variable to be explained by the state and the license and the month. And this will give me a nice summary of the coefficients in the model. And so you can see there that some of the, here's how you read it as well. I won't go into too much detail, but anything with stars near it is a significant variable. So that's significant in that it has quite good explanatory power. So the different states do have some good explanatory power. The different license types, not so, and the month variable looks fairly unimportant. So all I do is I take out the month variable and I get a more simple, parsimonious model that still has really good explanatory power as well. So the different states and the credit license, I would include that, even though it's kind of borderline whether that's significant or not. So then what you're able to do is then take the results of that model and to predict it onto that test data set that you had before. So splitting by training, we trained it on the training data set and we want to predict the results onto the test data set. And show you the test data set. So this is the actual here, the actual count, and this is our predicted count. And so you can see they're generally pretty close, but the predicted is going to be a bit less than actual because we were training the model on previous years that were actually lower than what we're expecting the latest years to have. So this one line here of code as well is going to transform our data from being kind of like a wide shape to being long shape. So it's going to stack almost like we did with our AFS and credit licenses together. It's going to do the same thing with our actual and predicted. So I'll just show you how it's, so this is what we start with here. So we've got the actual and predicted. Sorry. And here's what we end up with. So what we've done is we've got these two new fields called variable and value. And on the top we've got count, and on the bottom we've got pred. And this actually helps a lot with our graphing and to totally reshape the data set that way. And reshaping that in Excel or something like that might be a prohibitively complex exercise. In R, it's just like one line of code. So now we're getting to building our web app. And so with the Shiny, we just have two main components. One of them's a UI component, one of them's a server component. And to run the app, we just have the UI and the server component together. So I'll actually have to jump back here because if you run it in Google Colab, it doesn't actually do anything because of the runtime environment. It just says listening on, blah, 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 but doesn't actually do anything. But I'll show you here. So this is just the last bit about building the app. So for the UI component, I specify that I want a fluid page. So that's the big structure of what I want. Within the fluid page, I want a title panel, which is just going to be the title, and it's going to be that across the screen. And I want just there to be two things. I want there to be a sidebar on the left and the main panel on the right. So that's the sidebar and the main panel. And within the sidebar, I want there to be a panel which has a drop-down where you can select, and you can select the state, and that's what that's saying. And so there's a little bit of code in passing the variables to and from the different server and UI functions, but the server function has this reactive element to it, which takes my data set and it's going to filter, it's going to subset for the different state. So that's what that does. But that input, that subset that gets selected is passed back to the UI component. And in terms of the output I'm just rendering a plot, and that plot is a ggplot just like we had above. But the ggplot as well has whereabouts I'm going to be passing something back. I think we're going to be passing state back to the ggplot. Well, first of all, that function of create a subset is just going to happen there. It's going to run, this create subset is happening as the input, the data set to the ggplot. So it's really just a subset. So when we run it, we are able to, from the sidebar here, pick a state. It's subsetted, and this particular plot is run, and it's updated in real time. So it's a very simple demonstration, but it's a really good way to be able to show your results to someone as well. And these types of web apps can get a lot more complicated, and you can make them they often sometimes replace Power BI for some smaller places where the licensing costs of Power BI aren't going to be much fun, so they sometimes do this in R instead. So that's it. So that's within the one programming environment, everything from getting the data, cleaning the data, merging the data together, doing some exploratory plots, and then building a data product, all within the one environment. So R programming, it's really powerful stuff. So that's pretty much all I had. Does anyone have any questions on that? No, does that look scary? Was that? It's a lot probably scarier looking than what it actually is. Does anyone know Python or something like a programming language? Yeah. So the transition from, I would say there's a couple of things. So with R, I think of R as being research. So a lot of statisticians, a lot of people that are researchers, a lot of people that don't necessarily have good programming skills, like me when I started, they find it easier to go into R. Python is probably better as well for production machine learning type systems and for deep learning and for that sort of stuff as well. So Python is more computer scientists, R is more statisticians type people. But there are so many, there are thousands and thousands of these libraries in R that will make your whatever problem you're working on a lot easier. So for instance, if I'm looking at doing some crazy thing where I'm trying to work out string distance, if a word is similar to another word, well, someone with a PhD has written a module on that I can just pick up and use. It's really quite amazing. So if you're doing even something about wind turbine or something like that, I guarantee you there's someone that's written something that you can just leverage. And so in this case, someone's written some software that wraps JavaScript to create web apps. It's truly astonishing just what's out there. So yeah, I was going to say that's a bit of an introduction to R, and I'll be around if anyone has any questions. Okay, thanks.